This is our tutorial for our introduction to systems of equations in our fourth week of distance learning. So we're going to look at the different solutions and how they would look on a graph for systems of linear equations. The solution to a system of equations, if you remember, is the point of intersection. So I'm going to go ahead and put that on there. And if you're wondering what that means, the point of intersection, that's the spot where the two lines would cross. So I'm just going to put that it's where they cross. Okay. Now, sometimes lines don't actually cross. If you look at this very first example here, this picture, you've got a blue line and a purple line, and those lines don't cross. Those lines are parallel. So I'm going to put that up top. And what it says over here to the side is lines that have the same slope but different y-intercepts are called parallel lines. These lines never touch, and since they never touch, it says thus having no intersection, which means they have no solution. So I'm going to write that down below. So if it's asking you what is the solution to this system, the solution is that there is no solution. The reason? Because the lines are parallel and they never intersect. Okay. This next one, it actually looks like there's just one, but there's actually two lines there. And if you read the description, it says two lines whose graphs are directly on top of each other. Everything's the same. They have the same slope. They have the same y-intercept. These are called collinear. And in fact, not only do they have the same slope and the same intercept, y-intercept, but if you keep reading, it says these lines have all points in common. So every single point on the graph is the same for both of them, which means they cross or intersect everywhere, because intersect just means where they touch, okay? Well, so that means that they have every single spot is the solution, and since we can't name them all, we say infinitely many solutions. And I'm also going to label that up top on there, that these are collinear, and they have infinitely many solutions. Now this last graph, for example, really is more about what was happening at the very start, where it says the solution to a system is where they intersect. And this one does have one solution. That one solution is right here where those two lines intersect. Okay, so I'm going to label this. Now, in order to actually talk about the solution, we need the coordinates. Okay. Remember, coordinates is always x number first, y number second. The x number is the across number, the y number is the up and the down. So if I look at that point, here's my x-axis. How far across is it? It's right there. So from the origin, that's 1, this is 2, 3, that's 4 across to the right. And then if I look at where it is on the y-axis, the y is the up and the down axis. Again, from the origin, that's 1, 2 up. So the solution is 4, 2. And the thing to remember and to notice, you either have one solution where they actually cross. So I'm going to put one solution. You can have infinitely many if it's the same line on top of each other. Thus mean they cross or touch everywhere. And then you can have no solution if the lines never cross, never touch, never intersect because they're parallel.